So this is my time in the sun. I have been given, I think 1 hour 2 years ago, I think it was 2 hours last year. We're now pegged at 2 hours, I guess. Otherwise 3 would have been obvious. So 2 hours to give you the worldview from product management. And I love this for 2 reasons. First, I get to tell you what I think. So we're going to spend about half, maybe 2/3 of the time to do that. I have some guest speakers with me that will, of course, just tell you what I think, but through their own words. And then last year was such an amazing finishing touch for me for the event. We had a really great conversation towards, almost felt like a town hall. So I'm going to be using all my tricks to see if I can get you guys to give me feedback. Because, of course, as a product manager, what you try to do all day, every day, is to understand how you're perceived and what we can do better. So while I will do some talking, more see it as a means of getting you guys thinking, and then we'll end with hopefully a good conversation and feedback. And I would also compare with some of the feedback we got last year. It's really fun, actually, to see how or if things change, and if they change, if there's any directionality to it. So a little more specific, I will do some more introduction. Then I will invite Charlotta from our engineering team to talk about one of the topics that I find to be the most exciting going forward. She has been doing some intern work around how we can marry Yang with something called Merkle Trees. I will stop at that, and I will have her explain to you what that kind of tree is. I will, of course, go through the roadmap. The tricky thing with the roadmap is that we pretty much talked about it. You know, we're trying to be transparent at this event, so we'll talk it through. So I'll tell you that will be pretty short. Then we'll have Thomas from our technology team to talk about some of our radar efforts, things that are coming in, but they're not really on the roadmap yet. And then it's time for a wrap-up, and I believe I am the last speaker. So hopefully I can have your attention for these 2 hours, and let's try to make this as interactive as we can. And I'll do this now. I haven't prepared them for this, and I don't know how many of them are in the room. But I'm going to actually ask the guys in my team to stand up. One and one, because one of the things that I want you guys to know is who we are and what we do, such that when you feel you have a question or feedback, you know who to turn to, right? We don't like the sense we get from some customers that it feels like we're remote, that we're behind a number of people. We want you to understand that whenever you have something you would like to share, critical feedback, and if you have it in you, actual praise and positive feedback, these are the people to talk to. And this is actually my team. So these guys report to me in some capacity. And we are the product management team, or what we perhaps would call the engineering product management team. So we take care about for the vision and the roadmap and the details here for the NSO product, so the core platform, for what we call the core function packs. I think you've heard that mentioned once or twice before. Of course, that includes the NEDs. And among the core function packs, we have the NFV orchestrator. And more recently, we're also helping our VNF manager. There's a product called ESC that's being developed out of Canada, is coming in under this team. So that's the kind of scope that we have. So if we start with Niels Petter, who I just saw, if you wouldn't mind standing up. So this is Niels Petter. He sits right next to me in Stockholm. He does the NSO product management, meaning the priority meetings with engineering. He's the roadmap up to date. He talks to a lot of customers. So anything around the NSO core platform, that's Niels. Is KJ here? Ah, perfect. KJ runs product management for a core function pack. So I guess a large part of that is the NFV orchestrator. And then we have a couple of other core function packs around about SD-WAN, SAE, and a couple of other acronyms. But anything to do with core function packs, that's KJ. We have Omar. The most recent addition to the team, we're so happy to have him. He does our go-to-market and messaging, meaning that he's actually plugging that hole. We get a lot of harsh feedback, both externally and internally, that we are the best kept secret, because we are really, really bad at telling people what we do. Omar is the key to change that, for sure. Niklas, well, he was on stage just that, fast clap. Anything to do with developer communities and little events like this, that's of course Niklas. Fredrik Svan. Ta-da! You all know him now as Nadam Man. we could call that customer success. So he takes care of actually helping customers use NSO in an efficient manner. Okay, so I'll also try to summarize, right, in a little movie here, what it is exactly what we do all day, every day. And I did look quite a bit after a good way of doing this. And I don't know of any better way of doing it than this. Here's the thing though, it actually isn't that amazing? We made it fly. Right? And all snarky comments about the fact that it's not even cutting any grass anymore, leave it. I'm just going to let this move until it does a looping, because that's when I had snot flying out of my face when I saw it the first time. And don't ask me how it works, but here we go. It is a beauty, a thing of beauty. So while these guys, the manager of managers, whatever, are on the ground, this is what we do. Try to get this thing to fly here. Okay. I hope that's the last lawnmower joke of the day. But I wanted to kick it off on the really technical end, and I told her that this is likely going to be the most technical presentation that we have on this event. So hold on to your chair. This is Charlotta, and again, she's an intern. I think it's the first time she presents for a bigger audience. So we will let her run through her content, and we will gather the questions between him and her until afterwards. And again, this is a topic that's very, very close to my heart, because most of you, or many of you, have given pretty harsh feedback on some of the runtime behaviors of NSO around about updating YANG modules, or updating the system while YANG modules are updating. So this is one of the things that we're doing to approach that, and we have the fortune to actually find Charlotta and have her work on something that we think will really cut to the heart of this problem. That's about as much as I know myself, so I will leave it to Charlotta to take it over from here.
Okay, so as Carl mentioned, my name is Charlotta, and I did my master thesis work here at Cisco. So I'm going to tell you a bit about what I did. So the purpose of the work is to implement a hash tree inconsistency detection for YANG schema upgrades. And these schema upgrades happen when a change is made to the NCS data model. And this can, for example, be when a net is upgraded. And this sparks an upgrade procedure where the old and the new revisions are compared to each other in order to find where the changes are. So this procedure is pretty slow as it's done today. And so the purpose of my work was to speed up this procedure, this inconsistency detection procedure, by using hash trees instead. So this hash tree algorithm will detect which nodes of the YANG schema have changed between revisions and are therefore in need of an upgrade. So I'll start with a brief background. And of course, to build a hash tree, we need to use hash functions. And the hash function maps some data of arbitrary size to a fixed size output. And hash functions are deterministic, which means that the same data will always give the same hash. So Merkle trees are a data structure used in, for example, Cassandra and Dynamo for inconsistency detection between replications of data. So this is where the idea came from, to use Merkle trees to detect inconsistencies in these YANG schemas. So a Merkle tree is a hash tree, and each leaf node in the tree is a hash of its corresponding data block, and each non-leaf node is a hash of its children nodes. So this is an example of a Merkle tree structure, and we can see here we have data block A to D, and for example, the leaf node A of H is a hashed version of data block A, and the node H of AB is a hash of its children nodes. So it's a combined hash of H of A and H of B. And this continues up the Merkle tree till we get to the root, and the root is then the hash of the entire tree. So it's kind of like a fingerprint for the entire data set. So this hash tree structure enables easy identification of where changes occur to some data. So for example, if we have a change here to data block D, that would mean that the hash of D changes, which would mean that hash of C and D changes, and this branch is changed all the way up to the root. So what have I done then? Well, my work consisted of three main parts. First, building the hash trees for each schema revision, and then implementing the inconsistency detection, so two different hash trees can be compared to each other. And then, of course, performance testing to determine if this hash tree approach can actually improve the performance of the Yang schema inconsistency detection. So, when building the hash tree, the question that needs to be answered is, how can we represent the Yang schema as a hash tree? And each Yang schema revision will need to be represented by its own hash tree. And data in Yang schemas are already in tree form. So how do we preserve this tree form? Because for this work, I choose to preserve this tree form since another alternative would have been to serialize the data blocks and build a Merkle tree on top of this. This would make a more original Merkle tree structure. But in this case, we would have to find some way to map some node data to its original placement in the original tree. So it was deemed easier for this work to just preserve the Merkle tree structure so that when we go through the Merkle tree, we can easily know exactly where the placements of the node is in the original tree. So how to then preserve this existing tree structure when building a hash tree while preserving the properties of a hash tree that says that if a hash is changed, we need to traverse the children of the node. So the hash tree is represented by a hash version of each node in the Yang schema. And the hash node representation consists of a name, of course, to be able to identify the node. And we have data hash, which I call the hash of the node data. So each Yang node contains some data about this node. For example, the kind, if it's a container or a list or a leaf, or the type. In the case of a leaf, we can have, for example, a value that can be a string or an integer. And all this data consists in a Yang node, and this data is then hashed. And this will allow us to see if a node's data has changed in some way by checking this hash. Then we have a child hash, and this is a combination of all the node's children's node hashes. And the node hash is what I call the combination of the data hash and the child hash. And the reason why we need this node hash is, for example, if we were instead to have combine a node's children hashes together, then all the hashes would be empty because a leaf has an empty child hash because it has no children. So a parent of a couple of leaves would have a combination of empty hashes which would just be an empty hash. And so this gives us no useful information at all, of course. And another alternative would be to use the data hash. And in this case, a node would have a combination of its children's data hashes. So in this case, we can't see if one of the children has changed, which is an improvement. But if some of the grandchildren have changed or anything else further down the tree, in that subtree, we wouldn't be able to detect this at all. So that's why we need this node hash, which is a combination of the child hash and the data hash. And then, of course, we need a list of children nodes to be able to traverse the tree. So this is a very simple example of a Yang module called system. And we can see it has a container login, which has one leaf node, and a list user, which has three leaf nodes, name, full name, and class. So when we convert this Yang tree to a hash tree, we need to traverse the tree step by step till we get to the children, or to the leaves. And this is because, of course, if a node is dependent on its children's hashes, we need to hash the children first. So we build a tree from a Yang tree to a hash tree from the bottom up. We start with the left branch here and convert message, and then log in. Here it's now a leaf node, a hash node. Then we need to go down the other branch and merge convert the leaves. And then we merge login and user together to form the root. So now the whole tree is converted from a Yang tree to a hash tree. And that's when we can later do the inconsistency detection. So how does this happen? Well, the inconsistency detection starts at the root of the tree. And we start by checking the node hash, which I mentioned before is a combination of the data hash and the children hash. So if the node hash has changed, we know that something has changed in the tree. And this could be either the data hash, which means that this particular node has changed, or it can be the children hash, which means that something else has changed in the subtree of this node. So if there is a difference, we move to step 2. Otherwise, if there's no change, we can go on and check possible siblings because nothing has changed in this subtree. And in the case of the root, we're done. We don't actually have to do anything else. We have checked one hash, there was no change, and we don't have to do anything else at all. But then if there is a change, we go to step 2, and that's checking the data hash. And if we find a change to this hash, we know that this particular node has changed. So we detect an inconsistency. And in either case, we move to step 3 because we need to know if there's any changes to the rest of the subtree. So then we check the children hash. And if it has changed, we need to traverse the children because we know that there is a change to this subtree. And if there's no change, we do the same thing as before. We move on to the siblings, if there are any siblings. And in the case of the roots, we're done. And we found the only inconsistency, which was at the roots. So when implementing this, the tree is traversed as described above. But what happens then if there's a name change? Because each node is identified by its name, and a node in Gang doesn't have any other unique identifying features. So if a node changes name, there's no way for us to know if this is a node that has been removed from one revision and then another has been added to another revision, or if it's a name change. So therefore, we have to assume that a node has been removed and another one has been added. And we also need to handle the reordering of nodes, because if 2 nodes change places in the tree, we won't detect this as an inconsistency. For our purposes, it's the same tree. So how to handle this? I choose to match the names from revision 1 nodes to names in revision 2. So when going through the nodes, I check the node name, and then in revision 2, look after this name. And if I found it, that means that we have found a matching node. So we check the hashes as described before. If we can't find the node, that means the node exists in revision 1, but not in revision 2. So, of course, this node has been removed. And if we have gone through all the nodes in revision 1, and there are some left in revision 2, that means that some nodes have been added to revision 2. So to make this a bit clearer, I have an example here. And here we have the name change here. The node called class has been changed to group. So we assume that this means that class has been removed and group has been added. So here we go through and match the names. And we find a match for the node called name. It exists in both revisions. So we check the node's hashes. Then we move on to full name and we find a match. We check the node's hashes. Then we move on to class and we can't find a match for this node. So it's existing in revision 1 but not in revision 2. So this node has been removed. And then we have a node left over in revision 2, which is called group. So this node has been added. So when doing the performance testing, I need to check and compare only the inconsistency detection type. And in the current approach used at Cisco, the algorithm does the upgrades as soon as they are detected, so it's hard to separate the time it takes to find the inconsistencies and the time it takes to perform the upgrades. So therefore I needed to build my own simulation algorithm, and this algorithm simulates the current approach behavior. So it goes through all the nodes and checks all data fields for each node. So this is the one I use for comparison. And then some results. We need to determine the best, typical, and worst case performance. And for this, I needed to generate best and worst case scenarios. And to determine the typical performance, we need to use some real-life upgrade scenarios. And I used 6 different schemas of varying sizes. And then for each node, I checked how long does it take when we have no changes to the schema, and how long does it take when all nodes have changed. So these are the best and worst case scenarios. Because when all nodes have changed, we need to traverse every node in the tree and check the hashes for each node. And then to determine the typical case, I used 10 real-life revision upgrade scenarios. So here then we can see what happens when we have no changes to the schema, and the hash tree algorithm finishes in no measurable time at all, because it only needs to check one hash, and it's the node hash of the roots, and then it knows that nothing has changed in the tree, so we don't have to do anything else. And for the current approach algorithm or simulation prototype that I did, we can see that the performance depends on the size of the schema, because it will always traverse all nodes in the schema, independent of the number of changes. So in the case where all nodes have changed, we can see here that the hash tree algorithm is twice as fast as the current algorithm. And the reason for this is that the hash tree algorithm only checks 3 hashes for each node. So even though it traverses all the nodes, it only checks 3 hashes, while the current approach algorithm checks all the data that a node contains. So that's why the hash tree algorithm is faster. However, it's important to note here too that the current approach algorithm can tell you exactly which fields have changed in the node, while the hash tree algorithm can only tell you that this node has changed. So if we were to change the hash tree algorithm to also be able to detect each field, for example, when we integrate this at the current system at Cisco, then the performance can be expected to be slightly worse because we need to check 3 hashes for each node and all the data fields. But this is only in the worst case scenario, and it's a very unlikely scenario that every node in a schema has changed. So here I have an example of a real-life scenario, and this is the worst case real-life scenarios. Of my 6 schemas I used, this was the one that performed the worst. And we can see that even in this case, we have a significant improvement in performance here. In the worst case of this particular schema, between revision 7 and 8, the hash tree algorithm is still 5 times faster. And for this entire worst case schema, the algorithm is 30 times faster. So this shows that we can expect to have a significant improvement in performance for the hash tree algorithm. And here is a graph showing the relationship between the number of nodes we need to traverse for the hash tree algorithm and the time it takes to traverse them. And we can see that this is a linear relationship, which is to be expected. And what's interesting to note here is that in most cases, the hash tree algorithm finishes in under 200 microseconds, which means that in most cases, very few nodes actually need to be traversed for the hash tree algorithm. And there's only a handful of nodes that actually take longer than this. So, in conclusion here, for the best cases, the hash tree algorithm finishes in no measurable time. In the worst case, improvements depends on if data fields are checked or not, and in this case where they're not, the hash algorithm is twice as fast. In the typical case, we only need to traverse, on average, 1.5% of the total number of nodes, while the current approach always traverses all of the nodes. So this yields, on average, for all revision checks and all the schemas, a 200 times improvement in performance for the hash tree algorithm. And even for the worst case schema that we had, we still had a 30 times improvement in performance. So in conclusions, the results show that the hash tree algorithm significantly improves the performance of the inconsistency detection. So the goal of the thesis was reached. Thank you.
Who actually got everything? Awesome. That's way better than I thought. That's really cool. See, you made it.
Yeah, that's great.
Any questions? Dear, look at that. Oh, Victor, of course. Yes.
So, if you integrate this into upgrade procedure, right, you will also have to do the worst case where all nodes are changed. You will also have to recalculate the hash value for the tree. So if you look at the amortized complexity over a sequence of changes, have you looked at anything what kind of performance we get there, including the recalculation of the hashes in the update?
No, I haven't had the time, unfortunately, to look at this, but it's of course a factor that will affect the result when this is integrated in the currently used system. But that's a good point. But unfortunately, I have not had the time to do that.
They're fighting over the mic.
Yeah.
That's great.
I wanted to comment on your question. I think that we would calculate hashes at compile time, which means yes, there is a penalty, but it's not at runtime, so the customer will not see it.
Thumbs up from Victor. That's epic.
yeah, I forgot to mention that. But yes.
Next question.
For the performance graph that you showed us, for the number of the nodes, the time duration is very different. But did you see any differences that if you have many number of the nodes, the siblings, or if you have more in the depth, if you have more children?
Yes, that's a great question too. Of course, what I noticed in most schemas is that they tend to be more broad than deep. But I haven't either had the time to do some in-depth research in how this affects performance. But of course, if we have more siblings, a broader schema, and because all the siblings need to be checked to determine which subtree it is that contains the change, this of course affects the performance. But I will do further testing to see exactly how the breadth and depth impacts the performance.
Thank you. The new research will be making NSO faster in the future soon.
Yeah, hopefully. Yeah.
Thank you very much.
Thank you.
I got you on the comments.
Yeah.
Exactly.
That's where it takes. That's where the low mode takes off. That's it.
Yeah. I think you already answered part of my question on here.
There. Okay.
Okay.
Sorry, I couldn't find you.
Yeah. I imagine it would be done at compile time. The question would be, do you have any candidates for the hash function, and what's the compile time penalty you get for that?
Yes, so for the hash function, this was implemented in Erlang. So I checked which hashes were available, and I choose the MD4 hash algorithm because this is a very fast algorithm to compute, and it's a pretty short hash, only 128 bits. So this makes also the inconsistency detection faster at runtime. And so I determined that it's important that the hash function is fast, and of course we need to have a low likelihood of collisions, and MD4 is not entirely collision resistant, but it is, I think it was estimated that the risk of a collision happening, you need to do 2 to the power of 69 operations for that to happen. And that's still a huge number. So the risk of that happening in this case is pretty small. So that's why I choose it, because it was the fastest and still low likelihood for collisions.
All right, thank you.
Thanks.
I have a question.
Ooh, yeah.
No, so I wanna ask you. So when you perform the hash, do you do it in the binary data, or is it like the text representation of the node?
Yeah, so I convert the node to an Erlang binary and then hash this. And so that's basically how I compute the hashes.
And my last question is, when you say real case scenario, you show kind of like real case and migration 1 to 2. So should we translate that you took like real nets and move conversions?
Yes.
And so you have a 400,000 lines net that we all know which one was it, given those numbers. But that's the real time.
Yes, exactly. So I went to the commit history and took some randomly selected 10 commits for each schema and checked the difference. Yes, and you over there.
Yeah, I wanted to ask about moves in tree. If you take a whole subtree and move it to a different part of it, whether you've considered, is that one change that can recognize the hash?
Yeah, if
You've thought about that?
you mean if like an entire subtree is moved to a different branch. In that case, the hashes for the branch it moves to will change, and then it will compare the whole subtree to the children of the original node. So if we move the subtree to a node in another position, when we reach that node, it will see that there's a change in the hash for that node, and then it will traverse the children and check which nodes have been added or deleted. So it will only check on node level. It can't determine that, okay, this subtree that used to be over here is now over here. So it will only check that, okay, all these nodes are no longer here and all these nodes have been added.
More questions? Awesome.
So one more question. So you mentioned that you had significant time savings in the node traversal in the entire tree, right?
Yeah.
So did you do a depth first or a breadth first traversal?
It's a breadth first, I think it would be, because I start at the roots and then I check all the children of the roots.
Depth, right?
Yeah, right. Because I checked all the children and then I go to the leftmost nodes subtree and check all the children there.
Right. Yeah. So then it's in order. I mean, if you look at the traversals, there are multiple ways you can traverse, right? So root, left, and then the right.
Yes.
So it's in order. So like, what was the total time that was taken before? You mentioned that right now after the improvements that you made, it's really insignificant. It just takes milliseconds, right?
Yes.
So what was the time that was taking before you made these, inconsistency detection?
Do you mean then in the real current approach system?
Correct.
Or in, yeah. So I've heard that it can take hours in the worst case. And because, of course, I have implemented a prototype of the inconsistency detection used now, and compared with that one, it's hard to say exactly how much improvement we will have when we actually integrate this hash tree algorithm into the current system. So this is just an estimation of how much time can be improved.
Okay. Thank you.
Thank you.
Any other questions? One more.
Hi, thank you. That was a really great presentation. I just want to check if it's shareable in Develop Hub, I mean, whatever the Git repository, or is it
the
only
presentation?
a experimental?
Oh, you mean the code and everything?
Yes.
I don't know. I will have to check with the team and everything.
Yeah, I mean, Cisco internally.
Noted. Question noted. We will take a look at it, but I'm sure the presentation will be for sure.
Because actually we were kind of bothering to do the revision check for every time we did run some tools to do all revision check. Whenever the device has some different revisions, we will actually checking that. Sometimes even manually, since they already know which part has been changed.
Right.
If with this can be applied to the checking the revision, that would be great. Thank you.
Yes, thanks.
Yeah, that's cool. Oh, that's cool. All righty. Moving on. As I said, this will be briefer than what I usually do when people ask. Some of you most of you are kind of almost beyond the roadmap, but I just wanted to be, keep the prudence here and talk to you about it. You've heard, of course, 5.1 is out. 5.2 is coming. The reason why it's still bustling with energy back at the Sveavägen office is that we are working to get this out the door and then take a breather. And those of you who know of Swedish vacation, that breather is 3 to 4 weeks. And then we're going to throw ourselves at NSO 5.3. Currently, the target date for that is November timeframe, so it's probably going to be towards the second half. And the way we present NSO is actually we usually have a roadmap that says what did we just do, because again, we're not always very good at advertising what we already have in flight or what we already have generally available. And we talk about the next release, so that's pretty much locked down. You guys have already seen NetBuilder, or almost saw NetBuilder, if he had been able to ping his VM. There's always the pingings of the VMs. That's between a good and a somewhat shorter demo. And you've seen some of the web UI updates, so there's no particular news here. I think some of the things that will hopefully delight you and where we can talk about some of the future stuff is in 5.3, again, November. So we're going to kind of skip over this stuff here to that. Here we go. Okay. So what you'll see, there's a couple of themes, and we'll talk more about themes, and we'll also have a thematic speaker here that we are entertaining for each release. And one of them, as you can imagine, is to try to keep up with the appropriate parts of the standard development around about netconf and restconf and Yang, right? And for 5.3, we thought it was time to take on some of the more interesting protocol developments that has been going on in the IETF for a while. There's two things. These two are mostly related to people that consume NSO. So people that actually program on top of NSO, not so much in the MAPI sense, but actually using the netconf and or restconf interfaces to interact with it. Some of you guys use workflow tools, some people build API layers on top of it, some people use self-service portals. So these are features that hopefully and eventually delight people that work in those kinds of environments and want to understand what NSO is doing, and also, of course, tell NSO what to do in an appropriate fashion. So two developments in the IETF, one is Yang Push, and one has the beautiful name NMDA. So Yang Push is basically a means for a client to subscribe to changes. So think of it as a refined netconf notification with content. So a client can say, I want to know about the updates in the Yang-based data store. So anytime anyone changes it, let me know. So it's a cheaper, if done right, way of keeping in sync with what CDB basically has in it, right? So you don't have to go and re-ask for the full data. The second one is NMDA. I'm not going to be too much in the weeds about it here, but it's the effect of a pretty friction-rich conversation in the IETF around about the time span between you make a configuration change and that configuration change is in effect. So it actually came out of conversations mostly between router vendors. Some of them actually take their merry time between accepting an edit config, for example, until let's say the line card is actually running with the new configuration, right? So NMDA teases apart the intended configuration and the active configuration, or the running configuration. So it actually introduces a new conceptual data store in NSO. Turns out that this can be, we don't know yet, it can be pretty interesting in long-running changes. For example, anything to do with reactive fastmap and plan-based services, where we actually work ourselves towards the actual resulting configuration. This NMDA concept will actually show a client that is interested in it the fact that while the plan is running, or while the fastmap is running, or while the nanoservices are running, there is actually a difference between what the core intent is and what the running configuration actually looks like. So we hope we'll be able to make this into a instrumentable fashion and a way of consuming these things that will delight people, again, that run stuff on top of NSO. And another thing that I hope you can see, that the theme that we have, is that we have built over the last year or so a bigger web UI team. As we have customers now coming on towards us from environments where web UIs are more important, perhaps, than in our traditional markets, we realized that we have to kind of work on this. So we have a team that's now about 5 people that does nothing but think about the visual aspects of our UI, or the user experience, and of course the UI. To paraphrase our engineering leader for what's called Team Black, that's the web UI team, 5.0 is kind of a 1.0 for the web UI. We've caught up enough in the web UI that you can do most, if not all, of the initial basic operations that you do through, for example, the CLI. You can do that somewhat comfortably through the web UI. The guy is very patient and is very robust. We get a lot of opinions. That's what happens with web UIs, right? They open up for a whole lot of opinions. But we're happy about the direction this is taking. We're pretty proud of the fact that we're at a 1.0. And I would like to ask those of you who hasn't actually looked at the UI for a while, because you may have had a scarring experience from previous versions, to please do that. Please do that. Take a look at it again. Try to use it for some of the basic stuff that you're using NSO for. Hopefully you'll be delighted. Hopefully you'll also build opinions about what you think works and some of the things you may feel doesn't work. And get in touch. Get in touch with me or with Nils, who I introduced. And we will set up a conversation directly with Jacob, who's the name of the engineering leader in Team Black, because that's what he needs now. That's what we need now. We need feedback on the 1.0 version of the web UI that we are pretty proud of. And we think that particularly for some data structures that are very hard to visualize in the CLI and certainly in the REST interface, but that are useful for human consumption, we've nailed a couple of things really well, and we want to keep working on that. So for 5.3, what we're queued up is commit queue widgets, a commit queue widgets. You can actually inspect what the commit queues look like, which is actually a pretty good example of something that can be a little harsh to consume by constantly doing a CLI command and trying to catch the differences between each of them. Here we have the whole 2D space to play with. The middle one is actually the ability to transact actions, which is a little interesting because you actually don't do that until you trigger the transaction. So we're building more validation into the UI itself. And of course, we want to reveal LSA structures in the service manager. It's another pretty frequently asked thing around about the UI. Also something the UI should be very good at is to visualize and help people understand the structure of the LSA nodes from the view of a service. Another thing that we get a lot of feedback on, it's a consistent theme here, is around about high availability. Thomas will talk a little bit more about it, but for 5.3, we've lined up automating HA recovery. What that means is that, well, in certain environments, we have had, let's call it lazy recovery, meaning that we don't automatically restore the master, for example. It gets a little detailed, but we worked on how to actually recover from HA failovers in a way that is consistent and kind of along the expectations of our customers' operational culture. That's one thing that's really interesting with deploying NSO with our customers is that there's a lot of opinions, and what we're trying to do is, well, two things. We try to be not limiting in the way we build things. We try to be a good process citizen, but we also try to understand kind of the average expectation of what, for example, HA should look like. So you'll hear way more about this in the future. Again, this is a topic that Thomas will touch on as well. But for 5.3, more configuration opportunities and the ability to automate the recovery or automate the restoration of the master. Some of you guys hopefully are excited about this. It is a sticking point for some HA environments that we have in some of our customers. All right, so that was the roadmap that we have. Let me actually go back. Let me go back to the overview here. Here we go. So this is my first opportunity to ask. Is there anything on this roadmap that is missing for these two coming releases? Actually, mostly for 5.3. Anything high level that you guys would like to have on this roadmap that you think is missing? It's my time. What's that, Anne? Just coming up. All men back.
Yeah, thank you. Thanks for your presentation and update. It was quite interesting. A lot of updates. So, just want to know that what would be your roadmap integration with OneApp? So, anyway, with respect to 5G, all of the service providers moving to 5G towards mostly the even roadshow will be 2020. Even most of them launched. The trial for 2019.
Sure.
So, what is your roadmap or integration? On update on OneApp integration?
Yep. Okay, so OneApp and 5G or OneApp for 5G?
Yeah, I wanted to know that OneApp integration.
Okay, cool. Okay, so many of you were here last year, so you saw a more meaty presentation on OneApp. But OneApp is the name of a open source based, pretty impressive set of features that has gained a lot of attention around about communication service providers. It's an end-to-end solution for OSS, BSS, and service activation, and assurance and inventory, actually. So the current roadmap for OneApp is that we have an integration done by a team in Paris. There we go. You may stand up if you don't mind. So that's the man to talk to about our OneApp integration, not the least because he did it. So if you like, since we presented last year, we have, based on conversations both internal and external, we've actually built, or he has actually built something. So we've gone from PowerPoint to demoable content. I'll say that the rolling future of ONAP is going a little slower than we thought. So we are in POC and lab mode, and we're trying to figure out where our customers' heads are pointing. And no better way of doing that, of course, than being able to turn up in labs. So for anyone who's actually interested in it, I think coming to me or Stefan and team, and we'll be more than happy to set up a demo session to show you what we think is the right way to do this. And it's chock full of assumptions because it's a fairly loose field, but always happy to have that conversation.
Thank you, and thank you so much, Abhay. I have another question.
Go.
So most of the nodes, AT&T disaggregated network operating system. Because anyway, if you're talking about 5G, 5G predominantly works with the network slicing. So if you want to work with the network slicing, you're supposed to go for white box model, which will be like disaggregated model. So they also conducted some trials, it's working. So in that aspect, so how NSO can do automation, or what is the positioning in terms of automation automation perspective?
Yes. Okay, so really, you're asking such tome-sized questions. What's NSO's role in 5G, basically? So when people talk about 5G, they normally talk about network slicing. Network slicing is the ability to set up end-to-end isolated network services, normally stretching between the radio layer all the way up into the data center and a couple of things in the middle. Now, Cisco as a whole is coming together to provide a holistic end-to-end solution for 5G, because as you can imagine, or as you well know, it touches a huge swath of our portfolio. And there is one bigger project, and I think we actually have some of the team here, that is trying to tie together the domains, again, all the way from the backhaul, from the radio side, into the data center, using the appropriate domain controllers, of which, of course, Cisco has more than one, and do that based on a top-level service layer that's actually built on NSO. So it is something that we demo, it is something we talk about, but much like with ONAP, it's more a seed for conversation rather than a full-blown like strategic direction for Cisco, because this is another area that is shifting very fast, or shifting in a way that is really hard to tell where it's going.
Yeah, thank you.
Thank you. Any other questions on the roadmap? Wow, good. Finally, you haven't said anything for the entire event. Mike Runner, comment.
Sorry for my voice, I lost it during the event. Thank you for the presentation. And also, I don't see Kubernetes in the slides. And where is the cloud native disaggregation portion of the NSO and NSO?
I don't remember. Do you have that in your? Thomas now has that in his presentation, basically. Yes. So yes, we have thoughts, and we have experiments that we actually haven't even shared. If you look at the NSO developer GitHub, there are Docker examples. We have a small and growing set of customers that are actually deploying NSO on containers. But my current view is that most of our operational customers are still trying to figure out containers in general, and certainly trying to figure out how they want to deploy the application. So we're still kind of in a little bit of a reactive mode. You know, we try to prove different ways of doing it without being too prescriptive. And I think Thomas maybe you can fill out a couple of thoughts on that.
It was a stable set demonstration how to run NSO in Kubernetes, but I'm talking more stateless approach when you can divide the application.
I see. Yes. Okay. Cool. So so the mention of stateless here, right, is that of course stateless. If you think about 12-factor apps and things like that, the super well-behaved applications in cloud environments are preferably stateless. Now, NSO at its core has the need to be what database people would call point-in-time consistent, which actually forces us to have a little bit of state. And the way we're going about it right now with Kubernetes is that we use persistent volumes, or PVs, right? So the CDV data files is actually put on a persistent volume. Until we figure out how to do point in time without state, I think that's pretty much the direction that we're going to take. Two more based on that. I like it. wildfire effect.
I will second your question because yesterday we have the Kubernetes lab, and only basis on this data file sharing is very short. So currently you put the monolithic NSO on Kubernetes and on Docker, but it will still be valued for more flexibility to, for example, externalize the CDB as a component and not as a file system. I'm sure that was also that question. So we can expose each service in stateless thing and have a central CDB or something around that, and really take benefit about the Kubernetes deployment, and not just because it's trendy to put it on the ground.
I got it. So at the core, we kind of talked about this briefly last year. At the core of this again is that what I mean by point-in-time consistency is that the promise from a system like NSO to its users is that the data in CDB is valid according to Yang, according to the loaded Yang schema. Right? That is something that we promise to always be true. Start sneaking up here because it's coming into your domain. At certain points in time, we have to prove that all that data in CDB is consistent according to Yang. Right? That's a fundamental thing. So at times, we have to give ourselves the opportunity to check that that's true. Right? So we need both the schema and we need the instance data available for those points in time. And that's, we are trying to find ways around that. But right now, that is kind of the core of the challenges.
Is it on?
It's on.
It's on. I think this is a big topic, so I think we could probably spend 3 days. So perhaps we shouldn't rattle on it for the entire time. But I think another way to look at it is if we look at equivalent of running like an SQL database in a container. So if you look at CDB itself, the complexity around NSO is not so much about the data store, where you actually store the information. It is about the transaction engine. So think of NSO together with the device as the entire database. So just ripping out the CDB process and putting a container, it's not obvious what that would achieve. There's a lot of very nice things around Kubernetes and container deployed applications from an operational level, making it easier to upgrade, making it easier to sort of get distinct parts. But we spend a lot of time researching this, and we need to be very focused on what is the problem we're trying to solve, and just sort of externalizing where we actually store the bits and bytes. It will accomplish very little in how we can improve performance, scalability, etc. There's more to it, since we actually have, again, what we write to is actually the devices. But it's a broad and complex and hard topic, but we definitely spend a lot of time on it.
Before you come up here, there was one more question.
Go back to the largest.
Hello. This is regarding the communication between NSO and the real devices. It's an improvement because one concern is always not to touch the IP address configured that is in NSO and define that device. So there's a feature to add a secondary IP address in NSO to identify one device. In case we touch the first one, we can get the communication with the real device. We get the secondary IP address, for example, an inbound and outbound management IP address that usually exist in the devices. And also, is there any thought to evolve the communication
so
in
more than
IPv6?
more than one IP address in some prioritized order per device?
Yes.
That's a feature request.
Yes.
That's great. I hadn't thought about that. Yeah, he heard it. Let's talk about that. I don't see any particular issue.
I actually think some of the nets can do something like that. You're looking nervously at something. Or we just make a note.
Let's make it up. Okay, so that unless there are further questions. Any other questions?
Yes.
Okay.
Trying to explain us the CDP performance. So the question is, see, in the real world, if we're talking about service provider, networks is huge. So today maybe the 100 device, and tomorrow maybe the thousands and then those packs. So now I've designed the NSO installation machine. That's a parameter machine nowadays. So maybe some lower case, for example, CPU, RAM, something. Today, for example, the current status, I've designed that hardware, but in future it's going to expand. So by the time, what is your recommendation? How can I expand the hardware to support the large scale deployment? In case if it is CDP, then if the device get increased, yes, I suppose my hardware is supposed to get increased. So if I want to add more, so what is your recommendation?
Okay, so broad question. But most of the pressure on a machine like that is actually RAM or memory size, right? So it's about making sure to provision the appropriate amount of memory. Now, for certain of our customers that has on the excess of 100,000 devices, that actually won't fit in commercially easily available RAM. So that's where LSA comes in, right? But it's one of these questions that I know some of you guys have been asking questions like this for a long time, and we always get really squeamish when we talk about it, because it depends on the load patterns and it depends on how you group your devices. But that's normally what runs into limitations is the RAM size or memory size for very large networks. And that's where LSA comes into play, where you can distribute the device population across several devices. I would say so.
No, I think it is for horizontal scaling in NSO deployment. LSA is the recommended architecture for doing that, and having more an hierarchical cluster of NSOs, basically.
That's great.
So you can have 50,000 on each node and tie them together in an upper layer.
So I have the same, based on your answer, I have another question. Sorry. For example, today I didn't choose the LS architecture. I chose one machine installation, which is like 100 devices. And tomorrow I'm thinking that I want to go for 1,000 devices, which is predominantly going to support LSA model. What would be the recommendation model in CDP?
So is the question for migrating from one box into a bigger cluster?
Yes. And
I think that's I have one of the themes here is sort of operational enhancements, and I think that's an area where we acknowledge that having more tooling and more flexibility in changing how the deployment looks, moving devices and services between devices to be able to do that easier. Because today you can definitely migrate from one NSO architecture to an LSA architecture, but it's not a flip of a switch. You would have to do work in migrating that. You have to divide it up. You have to sort of have a conscious architecture and approach to that. So if you are looking into how you would design your system now, and you know that you're going to be in a big sort of distributed environment, I would probably design it with LSA from get-go, if you know that you're going to be there in 12 months or something like that.
I think that's the transition to your part of the presentation.
Yeah.
Thank you for the
answer. We can deep dive in the corridors.
Thank you.
Take it away, Thomas.
Thank you. This will be a 100% lawnmower-free section. As I said in the introduction presentation of this event, I run a technology team. We work hand in hand, of course, with Carl and the product management team, but also our fantastic engineering team. We spend a lot of our time researching, sort of figuring out where should we take our product, what should we do. Not so much perhaps in the last or the coming releases on the roadmap. Of course, we spend a lot of time with Carl in helping prioritize in the roadmap, but what should we do after that? What's sort of our radar look? And I think looking back a couple of years, a lot of the LSA is one of them, but also some of the brownfield deployment and functionality around that is certainly something we sort of had as a theme going forward, and that is now in the product. So, and if we look at NSO, it's a big product. It has a lot of functionality. It's everything from southbound protocols and two-phase commit protocols to devices to northbound protocols to deep complex stuff like Merkle Trees. That's not in the product yet, but definitely cool research around that. So it's a lot of different expertise that's needed. And I wanted, before I go into this, I wanted to take the time to acknowledge our engineering team. It is a fairly small group of people. It is around 35 developers that actually work on NSO and conft. So we have over 150 deployments now, used in very different capacities, and it is a fairly small group of people, and a very, very smart and good team. I don't know, can I get the people from the core engineering team to stand up? Well, you've probably seen a couple of them. Not all of them are here, but 3, you're also allowed to stand up. Yeah. At least a couple of them. So I think a round of applause. And when I stand here and take credit for a lot of the research, it's obviously it's these guys that actually do it. I mostly stand here blabbing about it. No, so we have a fantastic engineering team, and a lot of work is done in research in how we can help you get better. And I wanted to take the opportunity to look at some of the themes that we're looking at and researching now. This is not on the roadmap. This is not stuff that I will guarantee will be in the product, but I want to talk about it and I want to get your feedback. So I'm going to present a couple of themes and a couple of sort of sub-areas that we are currently investigating and researching, and I will follow that up with some Menti love to get your feedback on what's most important for you. And then we can take questions after that. What should I click? Ta-da! So I think Carl mentioned that high availability is definitely a theme and something we hear both from our bigger customers, the usage of NSO internally, and it's sort of been brewing a bit. We know that obviously HA is used everywhere. We have a lot of things we want to do. Definitely our HA controller, and again, this is my sort of top of mind bullet list. Again, all of this might not happen, and I want to get your priority and input into this later. So don't be mean to Carl if this doesn't show up on the roadmap later. Or be mean to Carl, but don't be mean to me. That's so definitely, I think it will be interesting to see what we can do more about our HA controller, having more flexibility in automatic switching back and forth between master and slave. The sync performance between the master and slaves and more intelligence there, I think is something we have picked up. And that is sort of connected to the third bullet here, where we obviously, the end goal here is we want to have sort of a hitless upgrade. We want to be able to have an environment where there's no downtime, where you can do rolling upgrade without no downtime, and that is not possible today. And we know that the syncing between masters and slaves is pretty crude today. It can take a long time in big deployments. And again, I'll come back to this in the Menti part to get your feedback. What is top of mind for you, at least from a priority level on this. Operational enhancements, and I think that ties into the LSA question. I actually don't have that here, but I think that it probably should be here. We know that upgrading packages takes too long. It's a painful, and upgrading NSO takes too long, or it could be faster. Super cool research by Charlotta and the Merkle Trees, and I think that can be sort of hopefully one foundational technology to make that even better. I see our way of playing even better and nicer in container-based deployments. If NSO could restart and upgrade and start even faster, our role in a container-based deployment would be even better. So I think that could be good. The third bullet here is around tooling. I think there's a lot of things we can do there. Operational tooling, one, obviously, to the point earlier here, to handle your LSA clusters, moving things around, expanding. That is not as easy as it sounds. It's fairly complex, but also things like distributing packages, ensuring that you upgrade packages in a controlled way, ensuring that you have the same version of packages. Today it's a bit too manual. I think that's an area where we can do stuff. Performance insights or profiling. This is a topic that's very close to my heart. I think the first bullet here, just understanding where is the time spent in NSO. It is, if you take an intent request to NSO and when it actually hits the devices today, understanding what happens in the system, where is time spent, it's fairly complex today. There's a lot of good profiling, logging output in the new releases of NSO, but we haven't really tied it all together. I mean, I would love to see a good visual tool to really show you that here we have a validation phase, here's the create code here, or here now it's in the commit queue, and etc. I think that could help out a lot, especially in when we come into more complex reactive fastmap or nanoservice services, and also in LSA deployments where you have multiple layers of NSO core services. Scaling and sizing guidance. We have a super nice scaling guide that me and Victor whipped together 2013 or something like that. It might need to be renewed. It might need to be better. We have heard the loud and clear feedback that we need to have better guidance on how you should scope and create your size your deployments, basically. Both from a pure hardware point of view, but also, again, to the question earlier, when should I go with LSA? When should I do this? How should I divide my services, etc.? And I hope we can provide more guidance there. And it ties into the first bullet here. When you have an LSA cluster, today it's fairly hard to get an overview of where things are happening. And I think we could provide a lot more visibility today. The plan is, I think, is a fantastic feature that is sometimes underused today, that can provide a lot of visibility in actually what happens with the services. And I think we can build more around that as well. Developer tooling. I think we know, for the people that are on reactive fastmap services, it can become complex. It's sometimes a bit subtle what happens. I think nano services, even though it's still a bit unpolished, and we have a lot of things on the roadmap and the backlog to improve that. For me, it's sort of a foundational technology that we can now. We have a much more structured approach on how to do these reactive things, and it actually lets us build tools and sort of guardrails around it. So now more tooling around nano services and more ease of use for that, I think, would be interesting. Some kind of template studio is something we have talked about for a long time. Can we make visual tools or tooling around creating template mapping? You can do a lot of powerful stuff in templates now with the XPath expressions and the other template expressions. You can iterate over stuff. Can we create tooling to make it even easier there? We all love XPath, self-explanatory, but perhaps we could have some tools to make it easier to profile and see what happens. It's fairly hard to write XPath expressions, or at least I think. And the last bullet here, before we go into the Menti part, is tools around package creation, and I would say tools in general for integrating our packages into more of a pipeline and sort of a CI/CD environment. We can have more seamless integrations to source code repositories. I know I had a discussion with Victor yesterday around some better templating things for packages, etc. So I think that's an area where we can improve a lot as well. So this was a super fast overview of some of the themes and some of the things that we are currently researching in some kind of capacity, some more than others. Again, a lot of these will perhaps be researched a bit and sort of put in the drawer again and perhaps come up later, or some of them will be sort of prioritized on the backlog. And it largely depends on what you guys think, of course. We want to hear your feedback. So are we ready with the Menti? I'm hoping we just it worked. So we go to Menti and use the code 259087. So the first question is, if we look at these themes, and of course this is not, we have other stuff that we research as well, but if we look at these four, and there is a free text Menti coming up in the end, you don't get it yet, but yeah, please provide feedback. Why do you hate my performance insights? I thought I would. Oh, that's good. And I mean, I don't think I can say enough about how powerful this is for us to see. Because I mean, I spend a lot of time with our customers and internal users within Cisco, but having 120, 30-ish users of NSO in the same room providing the feedback directly, it's amazing. So, well, thank you. And also keep hammering. Well, obviously me, you're super welcome to contact me and the product management team with this feedback. I think we perhaps can jump to next. There we go. So if we look at the HA theme, looking at the quick bullets that I gave you, what would be your topic? Looks like our priorities would be easy.
A left tour and the right one. You gotta do a left tour to get the right one back.
Yeah, maybe. Yeah. Or probably. So perhaps we should just have a big yes. How are we on? I'm awesome. I think we can jump to the next one. Thank you, Menti guys. I don't know who's doing this. I'm just amazing. So for the operational enhancements theme, what would be the pick? I see a bright future for Merkle Trees. Sorry. I think we can jump to the next one as well. Performance insights. On profiling tools. Well, for me, the profiling tools, that's my topic. So I'm glad you gave me that win. Yeah. Okay. You can also see this that sometimes it's good to state the obvious to ensure that everyone sees it. It shall be done. Isn't self-explanatory. This is amazing. before we jump to the next one, the next one's going to be a free text field where you can say, what is your topic? If you got to pick one thing that would be the top of our backlog, what would it be? If you, before again, don't jump to the next one yet. We're going to spend a lot of time looking at this, so don't write something weird. And if you write something, if you can add something to explain what problem you want to solve. Is it higher throughput? Is it faster deployment? Something that we can actually sort of quantify to have a productive discussion internally. And if you have, again, feel free to contact us if there's something that you really feel we should understand. Go for it. Next one. What's the hate of Corem before? And again, this is super great. I mean, it's very valuable. I think we have stuff to. I think it was Victor colleague that was. You had a previous colleague that was nervous that all the good programs had already been written. But I think we have stuff to do for 1 year. Thank you. Thanks a lot.
Okay, Mentigo, thank you very much. Okay, so here comes a couple of bits and pieces, and again, we're getting closer to my kind of town hall conversation, and thanks to all of you who have already started doing the questions and giving the feedback. This is going in the right direction. So this, I just want to tell you, is actually built on some of the great work that Omar has been doing in my team here. And I found this to be actually a pretty useful way of talking about how we think about features. And hopefully you're not surprised to see or hear that we actually think about user types. Who would like this feature? And also, how much have we kind of given this user type before? And also, what happens between the user types? So this is the way we structure both actually kind of our internal conversations about who uses the system and what kind of needs do they have. And also, actually, is how we present NSO in initial meetings these days. We've found that being a platform product, two things comes to mind that are really important. First of all, who uses it, and where is the customer in their journey? So we've gotten a lot of great feedback on the fact that we've structured the conversations around this. And hopefully none of these people will surprise you, right? Actually, maybe we should turn them upside down, because our infra operations person on top here is probably more intuitively closer to the networking layer, because she is actually in charge of running the network. So many of you at least have, I know, a background here of actually being in charge of making sure that the network is humming along. The next level down is actually our service automation person. That person, we lovingly call Eric internally, is actually in charge of, for example, the self-service portal. is in charge of the OSS, might be in charge of the OSS, BSS IT and service providers, or the ServiceNow installation in enterprises. So heavily invested in making sure that NSO does the right thing based on what his customers or his users are doing. So hopefully Eric will be happy about the NMDA and Yang push as an example. He will certainly like the fact that we have Swagger generation for our REST-conf interface. They're a little underserved in my mind. We realize in many of our customers that if we can delight the people owning the CRM system or the OSS, BSS IT, if they think using NSO is delightful, there's a lot to win. Because we also see in many of our customers, the distance between the part of the organization running NSO and people consuming NSO can be pretty vast. And our future of the platform is our service developer. Most of you guys, I would argue, is either service developers now or going towards being a service developer. That's someone who can sit between what we call the business owner, which is the person that owns the success of the system as a whole, owns the offerings if it's a service provider, owns and supports the line of business if it's an enterprise. So the service developer, she sits between the business owner that describes what the network should be doing and the infrastructure operations that can tell her how to make the network do something. So literally she writes the service models based on the business owner's requests or wishes and maps towards the nets based on the infrastructure operations. And of course, Eric then, of course, consumes it for the business owner. So I just wanted to spend a couple of seconds on each of the two that we think matter. So we call her Ariel, right? She does everything that has to do with the network. Again, you guys either are or know a lot of these people, right? In charge of making the network hum along. Normally kind of benchmarks against a little pie-in-the-sky ideas of what the network should be doing. For service providers, Ariel's manager usually comes along and says we should be working as Google. If it's an enterprise, the pressure is normally from the applications team to say your network should be able to respond as fast as my Kubernetes cluster, right? She always feels she's a little behind and she's very tired of everything being blamed on the network. So we really want to give her a lot of the powerful tools that, of course, we think is inherent in NSO, giving her the abstraction, the interfaces, such that she can manage her network as a whole. But we see that she is actually slowly, and that's what's so interesting with the earlier Menti we did actually day one, she is slowly turning into the service developer. I don't know if you remember where we asked, do you classify yourself as a network engineer or a software person now? And then we asked in a little while, I think in a year or two, and how that dynamic changed. So even in this audience, we could see a shift away from network operations or networking people into software. The same group, which I think speaks a lot to the fact that our Ariels, again, are slowly becoming Agnethas. And again, Agnetha then is really good at developing new products and services. And the word service here, of course, can mean both end-user services, but also services that are related to operations. So software upgrades and all these kinds of things that we see our customers using workflow engines and other things for. So not specifically or only customer-facing or paid-for services, but also services that are necessary to keep the network humming. And of course, traditionally, she has had a hard time being relevant. Tooling hasn't really been around. And at times, she's had a hard time actually communicating with Ariel. We hope to go back to other presentations that we're doing, that NSO can really be the bridge for the network engineers and for Agnetha to get a comfortable way of actually developing these services on top of a nice little substrate. And the third one, it actually kind of explodes, right? She has a lot of expectations on software tooling, right? She has a lot of expectations on how development in domains like networking should work. And at times she's appalled by the lack of these very basic hygiene factors. For example, no actual structured means of testing things. No development test, no production test, no means of actually checking that her stuff actually works, or like Martin Åkerström said, she's relegated to actually testing in production, which for a software person like Agnetha is not really cool. So I just wanted to give you kind of a sense of how we're thinking about this by, again, showing you these four roles and how we really think of those, and how at the core of this, we see the Ariels turning into Agnethas. which should also tell you that the theme going forward here, you can actually see this now when you retrofit this into Thomas' presentation, that we're really going to try to serve Agnetha as best we can, because we think she will truly be at the core of the future, actually, of networking in general. Okay, so that takes us to the home stretch. And the way I'm going to structure this is we're going to do this. So again, just a show of hands. Who in here was here last year? One more time. Good. About half. So I'm going to do three things here. We're going to look at some of the numbers that we had in Mentees last year. We're going to stick to one particular topic, and then we're actually going to redo some of the Mentees from last year, which will give us a nice and dynamic view of if anything's shifting, and if so, what's the nature of those shifts. One of the things that really hit product management the hardest last year was actually this. This was amazing for us because it gave us a really nice and interesting view of where your minds were going, right? So ignoring the fact that NSO has an insight that we worked quite a bit on, this gave us a good view of what is it that we should be doing that's not maybe core engineering, that's making sure that NSO works with your preferred outside systems. So I wanted to take a moment to just show you that one and talk about what we have been doing. And as you can see here, at the time, and it'd be interesting to see, or actually we are going to do it at the time, Ansible really came out on top here in terms of interest for integration. And hopefully, but it's worth saying, if you've seen what we've done with Ansible, we spent quite a bit of time going back actually now almost 3 years together with the Ansible networking team, used to be Red Hat, is now IBM and Red Hat. And we put our NSO core modules. If you haven't seen them, just Google for that. It's actually part of Ansible since I believe 4.7. We've also gone the last mile and turned it into something that's called core certified modules, meaning that we actually take a little bit of support load if issues come in through the Ansible core repo. So we're really trying to make sure that we are a really well-behaved part of the Ansible ecosystem, built on some of the IPR or some of the ideas that we have put together with our friends over at Ansible Networking. And we actually had a pretty massive presentation actually last week, Monday, at Cisco Live in San Diego, called Batteries and Pipeline Included with Cisco, NSO, and Ansible. All recordings from Cisco Live is freely available. So if you're interested in the most recent tech update on what we've been doing and some of the tooling that are emerging around it, go ahead and Google that, and you will. I've tried it; it actually works. You will find it right away, and you will have 2 fantastic hours with me and one more person in a tiny screen showing off what we're doing. We have, of course, also a set of demos. The most basic one is actually now on the NSO Developer Hub. It is the really basic step-by-step how you start using NSO and Ansible, using NSO with a really easy to set up set of NetSim, and using really just the basic machinations going back and forth with Ansible towards NSO. And we have a couple of people that have put together some what I think really, really cool tooling around it. The one that I usually point out is one of our colleagues, Kevin Corbin, who's at his GitHub page, you will see something called Pang, the Pang tool. And the Pang tool uses NSO to generate a lot of Ansible assets by actually interrogating NSO. And that cuts kind of right to the core with what we're doing with Ansible, which is to make sure that you need to write less playbook content, right? You can actually infer from the network through NSO a lot of the things that you used to have to write by hand in Ansible. You can do that by just interrogating NSO. So lots of good work being done here, and you'll see more coming over the coming quarters here. We are in close contact with the team over at IBM now, and there's a couple of cool things that are coming down the line. Anyone in this room actually using NSO and Ansible at all right now? 2, 3, 4, 5, 6, 7, 8. It's like small hats. I like that. 7.5, 8. So cool. 10 or so. Interesting. Anyone using NSO and Ansible in production? Loosely. Wow. Cool. Let's talk afterwards. Awesome. Fantastic. All right. So that's Ansible. Second in line here was actually Amazon. And look at what we did. Look at what Omar did. Look at the top right. We put Amazon on our net slide. So everybody knows now. But yeah. And so we actually have one. And I don't know if you know, and this is maybe one of the things that we should practice more on, or talk about the nets that we actually have, right? So we actually have a pretty rich Amazon AWS net. And of course, this is just a small part I put it together really easy. But you can see that it's actually got support for bringing up and lifecycling VPCs and subnets, and even VPC peering connections using their publicly available APIs. So this is a pretty feature-rich and pretty feature-complete net for managing your basic foundational building blocks for AWS to build service chains and other, if you like, networking constructs using nets. And actually the third one here, I believe, was, ServiceNow. So I'm going to take the meme route out here and say it's actually, stay tuned for this one. We have code for it, but we haven't actually come up with a good way of exposing it. It's a little bit particular, the way ServiceNow works, but stay tuned and we'll make sure that we'll tell the developer community when we publish the work that's already been done. So for those of you who are interested in that'll be interesting. Anyone in the room interested in NSO and ServiceNow? I'll say for professional reasons. Otherwise, it's too easy to say. For professional reasons, 1, 2, 3. Half a handful. Towards a handful. Interesting. All right. So that kind of concludes what we did based on that feedback. And again, like Thomas said, this is pure gold, right? Because you guys are a well-filtered subset, of course, of our customer base. We know that everybody who works on NSO is not here, actually quite far from it. Having an event like this in Sweden, of course, has its benefits by the closeness to the engineering team, but we know a lot of people that would have loved to be here but had problems actually getting okay to travel. So we weigh these types of numbers much heavier, of course, than we do with other perhaps conversations, because we know that this audience here is well pre-filtered. All right, so on to next. What can we do for next year? And here comes my Menti. Menti gods are on it. 44, 75, 78. Okay, this one we actually asked last year. It's something, I will talk while you do this, so please start responding. I will talk while you do it. This one spins our minds, right? And we get the question, we've had the question for a couple of years, can we put NSO on the cloud, right? And most of our feedback at that point has been, you just said your 2 favorite words, but there's no meaning to it, right? You said NSO and cloud, so those are awesome separately, but putting them together is a little harder to understand. So we're kind of continuously thinking about this, and we have some ideas and some directions that we could take. Thinking about an NSO portal where you can conjure, of course, an NSO instance for yourself. Populate that with the nets that you need and have maybe a connection to GitHub where your service packages would reside, and then figuring out a secure way that your risk management and SecOps team likes to have Amazon talk straight to your core routers, which will be a little hurdle to come over operationally. So we're always trying to gauge this. But I can tell you, I don't have the last year's Menti, that it's slowly and dynamically going from have not been considered a no towards yes. So that's really cool. I'm gonna always wait until 1:30. There we go. Oh, cool. Something to think of. Thank you. Next. Those are also questions that we've done, I think, 2 years in a row. No, actually, just only last year. So do you deploy services without manual intervention? Meaning, in the footprint that you know and maybe even own, are there still services deployed with manual intervention? I.e. something probably someone pays for or care for. Not so much day one, like DHCP and NTP or SSH keys, but things that someone actually consumes or expects from the network. Do you still deploy services, or do you deploy services without manual intervention? That is awesome. That's surprising. And what's surprising to me is that the blue one is actually bigger than I thought. I thought it'd be a solid 0, maybe a funny 1 or funny 2 or something like that. And of course, the level is somewhat depressing. 14 more. Make your voice heard. Almost 30. Close enough. Next. Okay, here's one. I like the fourth one here. What level of out-of-band changes, i.e., changes in the part of network that's supposed to be managed by NSO, actually occurs? It's not is allowed, but actually happens. I like the hardliners. Love the 6B7. Love it. And I think we have 3 liars. What do you think? 4. 5. Okay, that's what I get for saying that. Okay, that's more in line with what I remember from last year. We should have empty music. Horrible music that will tune out that 1:30. Okay, that's enough. That's cool. Next. So here's an updated version. And here's what I did sneaky. I removed the ones that we now support. You can't wish for that because it already exists. And I added 2 new ones. I added Terraform and I added SaltStack. Those 2 have shot up on my radar over the last year. They weren't almost non-existent in my conversations, and they've really gone through the roof for others. While we're seeing this, and anyone, those of you who have said other, please raise your hand, and you don't need a mic. Can anyone contribute another? Anyone of the 27?
Netbox. Netbox.
Netbox?
Netbox. Legislation.
Netbox, thank you. Okay, just shout it. 31 people. I have 1 now. Anyone? That was the smack into the embarrassment barrier. Come to me afterwards and tell me what other means, because it's just slamming the others to the ground. Right, we need a confession booth. An integration. Now you're just being mean. That's what you are. And all I got for that was Netbox. Okay. Google Cloud, Terraform, and Azure. Interesting. Very good. All right, next. Aha! Which is the world's greatest and absolutely only editor you can ever use. Then. This is for the Agnethas out there. This is why we want to pry your brain open and see what you think. It's okay, but you can shout support for your favorite editor. Yeah, someone said Edlin, right? Or Ed, right? Anyone bother to shout their favorite editor on the other? That's fine. More? No judgment, exactly. This is an editor safe space. It is. Any others? Notepad? Yeah. Notepad. I agree. I should have had it here. You're right. More. Eclipse, good. Thank you. More. PyCharm. IntelliJ. You actually use that? Why did you react like that? It was interesting. So you day-to-day use IntelliJ. Cool. Anyone else? Ed, of course.
Standard editors.
Awesome, that's great. That was by far the most popular one. You're such simpletons. It's crazy. Okay, next one. You'll love this. The world's greatest and only usable source code management tool or framework is God, they're so. Oh, now coming up on top. We should have bets on this before. This is fun. This one too is kind of slamming through 130. Anyone bother comment on the other? Don't do anything. Oh! Anyone? Fix it. So again, on the other buckets, shout it.
Gitty.
Google crowdsource repositories.
Say again?
Google.
Google. Thank you. Awesome.
Gitty. Gitty.
Gitty.
Yeah.
Yeah. More? That was 3 of each team. All right. 142. 142. Who knew that source code management would be that? 143. Oh. Okay, Mentigoth, next. Does your team work around a pipeline? I'm not in love with these terms, but I think you intuitively know what I mean. Someone's developing something, shoots it into something that manages it, maybe tests it, and out comes things. Okay, with a loose definition like that, that's good. Oh. Yeah, the other is good. Worth meditating on. This to me, guys, is amazing. We have a crowd of network automation people, out of which 84, let's say 2/3 at least, actually works around a pipeline. Which means that network as code, or infrastructure as code, seems to be, based on this data set, an actual reality already, which is actually pretty cool. This is way different than, I'd say, a year or two ago. So that's a big shift. And I actually don't remember, do we have one more? Yes, we do. Cool. Do you do automated testing, meaning testing that's not triggered by a human, except for, of course, the incoming Cool. So using NetSync, using virtual networking, meaning VM or container-based networking images, or on actual hardware. And note also, I did not have a no, not needed here. But no, not yet. Yeah, I should have had these all. That's right. Should have the marking. Is there one more? Aha! Well, actually, there's more. Yeah. Okay. How do you deploy NSO going forward? Bare metal, VMs, or containers? And note, of course, the going forward. I understand that most people do it on bare metal now, but where do you see this going for you? That's cool. Containers is making a steep entrance. All right, cool. Is there a next one? Nope. That was the last one. Okay. Well, first of all, thank you for that. Thank you. Awesome. Thank you for we are a couple of minutes before the hour, so I would just first of all like to open up for a couple of minutes of questions, general questions. Can I say something? Okay. Yeah, okay, so Nicholas wants me to tell you that we have a last kind of event-specific quiz later, but before we wrap up like that, I just want to open the floor Any questions of product management or architecture team? Anything you want to discuss or give feedback on right now? Here's your I guess, place to ask. Otherwise, you can always approach me in the hallways. Any broader questions? Anything? Oh, wow, good.
Hi, I have a question probably the most said. Do we have any roadmap or development activity to go towards container-based orchestration?
So when you say container-based orchestration, you mean NSO orchestrating containers?
Right.
That's a great. Don't give away the mic. I have more questions back. So, so broadly, we see two types of container orchestration. We can start with broadly two types. One is orchestrating containers as general application payloads. The other one is orchestrating containers as what some people will call CNFs, which is like containers that are particularly built to provide networking through them, right? Are you thinking of anyone specifically like NSO for container or CNFs or general container management?
General container management.
General container management.
Yeah, because I think what I'm going towards is like we have the VMF orchestration doing now.
Right.
Along with that, to tie the apps orchestration so that apps and networking tie together.
Right. Okay, so the general observation that we're making is that thinking that NSO would make a mark in general container orchestration is not very realistic. There are some very powerful and very effective and very well appreciated container orchestration tools out there, notably Kubernetes, right? So just to close that, generally we're not going to take NSO and try to compete with Kubernetes. Now, there are some particular applications, some particular environments where NSO actually makes sense, right? And the way I try to think about this is when the use case is network-centric, right? We believe, of course, that NSO's abstractions, NSO's way of viewing the world for networking is more efficient than, for example, the Kubernetes abstractions. Kubernetes is awesome for applications in tiers. We think NSO is great for networking constructs. In certain cases, and maybe this is what you're asking, we need a little bit of both. So in order to support the networking use cases, we need to use some containers, right? But where maybe the container applications is not the primary target of this. That's where we see a lot of interesting uptake. And one of the first ones is actually in 5G. That's one of the first proving points where the applications running, of course, in an EPC or virtual EPC are heavily, networking centric. Even though some of them behave like servers, right? They're policy endpoints and stuff like that, so they don't actually pass traffic between them, but they're stitched into an environment that is very networking centric. So and there comes the next kind of fork in the road. Now, do we believe in the Mano worldview with the abstractions of descriptors, what the ETSI is doing? Or do we think we should be doing something more native, kind of more conducive to the way Kubernetes is thinking for this? And I think we're like at 80% towards Kubernetes, and about 20% maybe of the conversations we're having with customers wants the Mano abstractions to stay, but backed by Kubernetes. We're very interested in both. We have proof points for both. And judged by the sheer volume, it's NSO talking to Kubernetes. We have some work around NSO talking Helm charts. That seems to hold some promise. But again, backing up, saying that doesn't mean that you should think of NSO as a competitor or even someone as a system that tries to be competitive or replace Kubernetes itself. Does that make sense?
Yeah.
Okay, cool. That was a tiny little question. One more? Awesome.
Okay, so hello.
Yep.
Okay. So I have a question on the HA, let's say operational enhancements, because I've seen that having an HA with active standby, and you want to do a package upgrade, let's say, in a production environment. When you do that, it's quite disruptive, right? You have to fail over and do the upgrade and so on. So I'm wondering if you could have this kind of two-tiered approach in the future, where you do the package reload on both nodes, but you place the thing in a kind of candidate, where you then switch over to the, let's say you're running of the new updated version, like after you've validated everything correctly, right?
Got it. Yes.
I can try to comment. So, I mean, first to acknowledge, yes, I think that's one of the core problems that we're going to solve. Exactly how we will solve it, if it's that way, I think it's too early to say. But we have the 20-pound brain people thinking about it. So, I mean, but that is at the core of that theme. Make it less disruptive.
Thank you.
Thanks, Carl. So my question is like, we do see a lot of these standards bodies coming out with Yang models, and we see a lot of customer stakeholders getting interested in it. But there is the other angle when we look at it where we make the model more complex than necessary many times. So do you have some views on how, you have done a lot of work on Yang, so do you have some views on how we approach those kind of questions? Or I mean, I'm sure this is not just, there is a lot of people who are actually confused by this.
Yeah, you're right. I have opinions, and lots of people are very confused about this. So actually, at the core of this, though, I think there's some awesome development. The uptake of Yang as a service modeling language is pretty crazy across environments like TMF, BBF, Metro Ethernet Forum, IETF, OpenConfig, right? So that's cool. They're taking, or at least they're working to see if Yang can be the service modeling language. Now what we're seeing is, the old software development law of plan to throw one away, right? Because inevitably, something that new and something that honestly mind-bending is probably not going to be right in the first roundabout, right? Especially for standards-defining organizations that do it by committee, right? That actually don't do it based on experience, but they do it by committee and by vote, right? So I'm a little, I usually tell people to be very careful with the current version or current generation of these Yang modules or service modules, and broadly for two reasons. You can, just by looking at the model, you can tell whether it came from kind of the OSS BSS crowd or if it came from the networking team, right? If you look at the L3 service model from IETF, you can see that it's basically router config, but they've kind of pushed it up a little bit. So all the nodes, all the nerd nodes, everything is available in the service. And of course, then you ask yourself, which OSS knows about a good VRF name or a good VLAN name? See what I mean? So it's chock full of resource layer details that are trickled up, right? And you can say the same thing with some of the TMF stuff. If you actually look at the model and you try to find service-specific parameters, you have to dig really deep. And when you get deep, you will see key value pairs, unstructured key value pairs. And you ask yourself, what's the point, right, of having a service model if the actual model with constraints is actually just key value, untyped key value pairs? So I think a measured approach right now is probably the best, i.e. calm down a little bit, don't rush into it. And the one thing that I usually say is talk to your OSS IT people, because what will be the deciding factor eventually, and of course in enterprise that's the ITIL or ITSM people, is what they can send. What do they know that they can send? Because that's what's going to be important anyway. You can come with the world's greatest, most normalized service model, but if the OSS IT or the ITSM people don't have that data that's required, then that's going to be of no use. So it's a little bit of both kind of, it's cool that it's happening, it's kind of first generation, and talk to your OSS or ITSM people is my general observation. Was there one more? Yeah, one more. Just because Niklas told me to stop, I'm going to go for one more. Oh, Mike.
Yeah, one of the major challenges that we have in our customer environments is to be able to preserve the service instance data of Yang nodes when the Yang nodes are undergoing revisions during the package updates. Today's demonstration on the Merkle Trees is a great stride towards addressing that.
But if correlationship could be established between these nodes, span across revisions, I think that will greatly help us address this issue of not having to write transformation logic to uncover or to attach relationship between existing device data model and the new service instance here.
Also, like annotated pointers or something.
Yeah.
Good point. Thank you. Last question.
Yeah. Maybe it's more of a suggestion for the conference itself. Yeah. So someone's been working with the NSO for a couple of years now, going to these conferences, you know. So I was thinking maybe we could also do some more deep dive session or two, like maybe where we discuss some code, you know, something that we did or someone did or you saw that customers do something that's neat but maybe a bit unconventional, or you know, maybe to and have someone from the core team comment on it as well, perhaps. You know,
something like a little workshop.
Kind of, yeah.
Cool. Yes. Point well taken. Absolutely. And more of that, please. You know, you don't have to do it now, but come to us and give us feedback. We're gonna pivot away from me into the actual event question itself.
Yeah, we will actually round off with an event survey where we will collect your feedback about the event and get any suggestions for next event.
Right, thank you.
Okay, so next math session. So if you were here last year, you remember these questions, and we're going to do these questions again so that we can compare and see if we improved or not. So the code you see up here, 542306. If I recall, we were about the same level as last year. So I'm glad that we haven't gone the other direction. Yeah, too Swedish. Come on, it's my job. That's on stake. Come on. Alright, so right after then, we will end with some coffee and some sweet, so that you can mingle around a little bit. So, I think that, yeah, I know that's more. I'm just waiting for it to settle. So we can take the next question. We only have a few questions, so we will soon release you to the coffee. So please state the main reason why you attended this event. It's free text. Developer help comes soon. Yeah, networking, that's what I expect. I mean, you guys want to meet each other, you want to share experiences with each other. Good knowledge. My main objectives are reached, I guess. Fun? Did I read fun? Weird. Good, yeah. Alright. I think we go to the next question. So, what do you want us to spend more time on? Was it a good mix this year? More engineering presentations. Good feedback. Okay, I guess it's pretty stable right now. Okay, take the next question. So, what do you want us to spend less time on? I can tell you last year you wanted us to have more breaks, longer breaks, so that you had time to talk. Yeah, it's decreasing. Yeah, we actually had more customer presentations this year. But one feedback that I got that I think is pretty interesting is that the use cases are more different than last year. Last year we saw more similar use cases this year. I think, was this the last question? Two more. Let's wait 2 minutes. So, about the NSO developer community. Yeah, this is actually what I expected as well. I see that many of the people of you that come here are not that active. And I hope that my work will make you more active and that you see more value in the community. And the more questions you ask, the more you engage, the more value we will see out of the community. So it's a give and take. And we will work harder to promote the community, to make sure that we stay on top of it. And we make sure that we answer the questions. We reach out to people that we know have the answers, because that's an important part of it. So I guess I still have my job. Okay, I can work on this. Good. Thank you. Next and last question. So, any suggestions for next year? Oh no, we had last week. Oh, I like that. Less salad. It is a challenge to serve 300 people food in like 15 minutes. Everyone should get their plate. Maybe work. Maybe work, yeah. All right. I think it's time for a coffee. And you will be nice again. One last thing. Yeah. So here. Yep.
Hopefully this was a good 2 or 3 days for you, and I just want to point out that this is Nicholas's project, and he really pours his heart and soul into making sure this is a good experience for everybody. So if we're going to wrap up, maybe you can wrap up with a round of applause for
Cisco, the bridge to possible.